Hi, pre-calc students. Today we're going to talk about verifying trig identities. And verifying is just another word for proving trig identities. And this is a unit here that is often very challenging for students. And what's challenging about it, I think, is that unlike some other math where there's steps involved, like, okay, this is your first step, this is your second step, this is your third step, do it and you'll get the answer that you want. This is more like a puzzle where you have to look at it and try to figure out what you can do. So that's sometimes what's a little bit frustrating because we give you tips on how to do it, but not really steps. Okay, we're going to give you some tools to work with here. This is the nice to know. Honestly, I wouldn't pay too much attention to it. I hardly ever use those. And you kind of know this anyway, that sine is reciprocal of cosecant, cosine is reciprocal of secant, etc. But this in green, this is really the one that we use a lot. So saying that the cosecant is equal to 1 over the sine and secant is equal to 1 over the cosine. That we use a lot. This is also something we use a lot, is that tan is equal to sine over cosine, and cotangent is equal to cosine over sine. Because one of the things that we're going to do is we're going to change everything to sine and cosine. That's most always, that's the first thing that we do when we're trying to prove these identities. Okay. So these are important as well, trig identities, so Pythagorean identities in particular. So this here, of course, this is Pythagorean theorem. It comes from a squared plus b squared equals c squared. So if you look at that, x-axis, y-axis equals the radius. Well, remember that, that if we had x and y, that this was cosine and this is sine. So this is just some background on where these three identities come from, right? So if I replaced x here with cosine, so if I replace this x here with cosine squared, and I replace this y with sine squared, and the radius, remember, if we're talking unit circle, that is 1. Well, that's where this first identity comes from here. That sine squared plus cosine squared equals 1. Now, this is also where we get the other two identities. This 1 plus cotangent squared. Well, if I take this original one, so if I take cosine squared, I'm going to write it the way it's written here. Sine squared plus cosine squared, right? It doesn't matter if it's sine plus cos or cos plus sine, but I'm going to write it like the identity in pink is written. Now, let's say I divide everything here by sine, sine, and sine. Okay? Well, what happens when I divide everything by sine is I get sine over sine is 1, cos over sin is cotangent, and 1 over sine is cosecant. Okay, so that is our second identity. So if you know sine squared plus cosine squared, that is huge because then you could easily come up with the other two identities. So this would be if you didn't have any notes on a test and you had to know these identities, it's a real easy way to memorize the other two. Sine squared plus cosine squared equals 1. That's pretty easy to memorize, especially coming from Pythagorean theorem. So I just want to show you the last one here. So if I divide everything here by cosine squared, I get sine over cosine is tan, cos over cos is 1, and 1 over cos is secant. Again, that's that third identity. So all of these come from the Pythagorean theorem, a squared plus b squared equals c squared. We're just substituting the x for cosine, the y for sine, and the radius is the unit circle 1. And then the other two identities just come from dividing everything by sine, or sine squared, and the other one comes from dividing everything by cosine. All right, but big picture is you need to know those three identities. So that was just some background on where they come from. Okay, so going back to verifying, what does it mean to verify? Verify is just another word for prove, okay? So if we're going to prove that the left side here is equal to the right side, I'm just going to work on one side, and I'm going to work on the left side. So I'm going to distribute x times x, x times -3, 2 times x, and 2 times -3. I will combine like terms. -3 plus 2 is -1. You can put the -1 there. And so basically, we have now proven that that left side is equal to the right side. So I'm going to go check, done with it. That's really the same thing we're going to do with the sine, cosine, all these different crazy expressions that you're going to see. We're just proving that one side is equal to the other side. These are some rules that we're going to use. We are going to work on one side only, and I would say that's a rule. It's very hard when you're trying to work on the left side, work on the right side, and show that both sides are the same. So pick the more complicated side, what seems to be the more complicated side. It's not always obvious, but once you do that, then work on that side and think how you're going to make it look like the other side. Big tip number 1, this is usually the first thing I do, is I change everything to sine and cosine. And then these are some other tips. Bring terms together by finding a common denominator and adding, subtracting. So key is bring terms together, but you find a common denominator in order to bring them together. Remember the Pythagorean theorem identities. So that's sine squared plus cosine squared equals 1, etc. Get rid of fractions within fractions. So what I mean by that is, like, let's say we have 2/3 over 1/2. Well, we can get rid of it by doing 2/3 times the reciprocal, okay? Or we could have multiplied the top and bottom by 6, but most often I think it's nice just to multiply by the reciprocal. That's almost the easiest. Look for common factors. So looking for a common factor would be like if, if I have x squared minus x, well, a common factor would be to pull out an x. Opportunities to multiply by 1. So what I mean by multiplying by 1 is multiplying by like sine of x over sine of x. Sometimes that's helpful. And multiplying by the conjugate, we're probably not going to use that too much, but the conjugate, so if I have, for example, if I have cosine of x plus 1, the conjugate would be cosine of x minus 1. And then we would multiply by doing this business here. Okay, we distribute. That doesn't come up too often, but keep it in mind. And then a final step is, if you get stuck, try the other side or work backwards. So sometimes you just get completely stuck and it gets kind of frustrating. Well, try the other side in that case. All right, so we're going to take a look at one. So I look here at the dividing line, and it definitely looks like the right side is more complicated than the left side. So I'm going to start by working on that. Use a different color. So first tip is I like to change everything to sine, cosine. So cosine is the same, sine is the same, but then cotangent is cos over sin. And notice that it's squared. It's squared. So I'm going to divide that up into, maybe I'll just do a different color just to show I changed it. We're going to do cos over sin and cos over sin. All right. So changed everything to sine, cosine. It's like, okay, now that looks like kind of a mess. But I think I can maybe at least eliminate. Notice that we have a sine over cosine there. So let's at least try to cross those off. So I can cross off this sine over sine. And I end up with cos on the top. And then let's make it cos squared over sine for now. Only because then it's at least just one fraction. So cos times cos is cos squared. 1 times sine is sine. Well, now I have one of these situations where I have a fraction within a fraction. So I'm going to multiply by the reciprocal. I'm going to take cosine times the reciprocal. So I'm going to go sine over cos squared. It's like, okay, and I'm really not even paying attention to the other side. I'm just trying to, we definitely want to make it one term, but I'm just trying to simplify it really. Now I notice that cos over cosine squared, if we want to divide it up, we can. This is cos over 1 times sine of x over cos times cos. Maybe a little bit easier to see, but then cos over cos crosses off, and we're left with sine over cos, and sine over cos, I'll try to make this a little smaller, sine over cos is tan. And that's what we want. Okay, so really, when we're working on the one side, I don't even pay too much attention to what's on the other side. I definitely notice that I want it to be one term, but I'm really just concentrating on trying to simplify it as much as possible. And that's actually the next section we're doing. We're just simplifying it. We don't have an equal sign. So, but the reason we're starting with this, at least we have a little bit more idea of when we're done. Okay, so I look at this one, again, it looks like the right side is more complicated. So I'm not going to pay any attention, or I am, but I just want to try to make it one term at this point. So cotangent. So cotangent is cosine squared over sine squared. So I'm going to change that. I'm going to keep sine the same because that's already sine. And I'm going to change this to 1 over sine. Okay? So this becomes cosine squared over sine squared. Sine over sine. That's going to cross off. And we're left with 1 over 1. Which is 1. Excuse me. So maybe now I'm going to kind of look at, I've got that cosecant on the other side. That maybe looks a little familiar. I'm just going to see if I look back at those identities. I'm going to see if this helps. Cosecant is equal to 1 plus the cotangent. Okay, cosecant equals 1 plus the cotangent. Let's see if that helps. So I'm going to just write that down. Secant squared equals 1 plus the cotangent. Yeah, it's 1 plus cotangent equals cosecant. That was the one we were just looking at. But then I look at this and I'm like, oh, well, this cos over sin is cotangent. That's the same as cotangent. And if I keep the plus 1, now I can just substitute that for the cosecant. And cosecant squared is equal to cosecant squared. So it's kind of just looking at these things, and again, when you see cosecant squared, cotangent squared, sine squared, cosine squared, when you see any of those squareds, make sure you go back and kind of look at those identities and see if anything rings a bell. Also, whenever you see a 1, so notice all of those have 1s in them. So that's kind of what rung a little bit of a bell with me, is that it's like, okay, we've got some cosecants, cotangents, but we also have a plus 1. So that's what made me think of the identities. All right, but a lot of times, you know, something else you might have done is you might have decided to find a common denominator and change that to sine squared over sine squared and put the two together. I think in that case, you would have ended up with the same thing as well. So there's not always just one way to get to the same place. So just keep that in mind too. Okay, look at this one, and both of these sides look kind of complicated, but I'm going to at least try on over here. I'm going to try to distribute and see what I come up with. So this is cotangent, cosine. So I'm going to move it over a little bit more. And this is cotangent, cosecant. All right, well, at least I have two separate terms. Now I am going to look at the other side because I notice I have two terms here. The other thing is I have the cotangent piece. I've got the cotangent piece. And then this one here is related to secant. So I could change this to cotangent of x. And if I want that to be secant, cosine is the same as secant over x. So remember before I said I don't pay too much attention to these kind of reciprocals? Well, now here I used it. Cosine is a reciprocal 1 over secant. I'm looking at the next one, and I want to keep the cosecant, it looks like, right? This cosecant, we've already got that. So I'm going to keep that. But then I'm going to change the cotangent to 1 over tan, because I can see the reciprocal there is tan. But then I think we've got it here, because cotan of x times 1 over secant, cosecant of x over tan. I'm going to bring this down. We have now proven that the left side is equal to the right side. Just keep in mind again, a lot of times you start it and it doesn't work and you have to go back and try it again. And I'm not really showing you that sometimes I do it too, and I work on it and I get stuck, and then it's like, okay, that's not working. I got to go back and try something else. So we're just trying to keep all these tips in mind. Okay, we'll look at one last one. So again, we're trying to prove that the one side looks like the other side, and we want to work on the more complicated side. This is another one where it's hard to see which one is more complicated, but I kind of look at the one on the right, and besides changing things to 1 over cosecant, or sorry, 1 over cosine or sine over cosine, it's hard to really know what to do with that. I'm going to try working with the one on the left. One thing I noticed about the left is that it's 1 minus tan squared. So I'm going to try to take this and distribute it. So we'll go 1 times 1, 1 times negative tan, negative tan times 1, and negative tan times negative tan is positive tan squared. Okay, I guess I'm going to erase this here. Tan squared. Okay. These two are like terms. So I'm going to say this is 1, -1, and -1 is -2. Okay, so I like that because if I look at the right side, I notice there is a -2 tan. So it's like, okay, that's looking pretty good. So now I'm going to keep that. I just want to think, how can I get secant squared? Well, I notice that I've got these two, and that looks like it might be an identity. So if I go 1 plus tan squared, and then this is still minus 2 tan of x. And if I look back at my identities here, wherever they are, I guess they're way back at the beginning here. If I look back, not quite that far. Okay, here we go. So it's that last one, that tan squared plus 1 equals secant squared. So tan squared plus 1 is equivalent to secant squared. And now the left side looks like the right side. Okay, so that one consisted of using the distributive property, multiplying out, and then recognizing a trig identity, that 1 plus tan squared, that is a trig identity, and we could replace that with secant squared.